It's welcome to Fridays and SimCafe with Simulation Australasia. And this week it's the speaker's Associate Professor Jonathan DuckWorth, who's talking about designing an interactive application for brain injury rehabilitation, which looks very active and very colourful. We're really looking forward to hearing a lot about it, Jonathan. Recording is on and the screen is yours. So thank you very much for doing this for us, and we're all looking forward to learning.
Yeah, no, thanks, Elizabeth. Yeah, it's a great pleasure to be here and present to you all. And I've heard so much about the group from Gillian, and so yeah, it's great to finally meet some of you in the group. That's great. So as Elspeth mentioned, I'm an associate professor in the digital design program at RMIT. And I'm also the director of an RMIT virtual lab called Creative Interventions, Art and Rehabilitative Technology, or SciArt for short. So I'm going to discuss a project that I've been working on now for a number of years, which is called EDNA, which started out as a project called Elements, which is an application for movement rehabilitation for patients who have suffered from traumatic brain injury or acquired brain injury. And also just sort of show as well some of the offshoots that have resulted from this project that research that we've been doing. So I'll just go on to the next slide. So just really as a summary of what SciArt is, it was originally conceived to bring sort of research in interactive media art, digital design, and game technologies and its application in allied health sciences. And so from its initial starting point in 2014, we sort of expanded that group into other research domains, including sort of nanoscience, computer science, engineering, and ethnography. And I currently have several PhD students who are working in these areas, and 2 visiting research fellows who are also exploring that sort of arts, design, science related areas. And the common thread across their work is often the use of emerging technology to produce sort of new pathways for sort of creative expression, where they're sort of developing either novel processes, systems, and also sort of intellectual property that comes out from that. So just as an example of some of the projects that I've been involved in over the years, John Power, who's currently a staff member at RMIT, who's doing his PhD, and his work on the left-hand side there is he's investigating how data-driven generative ambient media can make spaces calm places. And this work that you see, just that little thumbnail there, is a work called Locus Amionis, which is a generative virtual reality system that creates a gentle sort of journey through a naturalistic but imaginary landscape. And this work's installed in the Victorian Comprehensive Cancer Centre here in Melbourne. The next one along is Rakesh Padabanda's work, and his work is investigating how virtual reality games can be designed for practicing pursed-lipped breathing exercises. And this project's led to a collaboration with Breathing Labs, which they're based in Slovenia, and they developed VR games using breathing techniques for potential treatment of anxiety, for anxiety management and rehabilitation. Moving along there, we've got Trish Adams, who's a visiting fellow, and we collaborated with the Hearing CRC to develop a work called Disconnections, which was an exhibition of 2 multimedia artworks which were created specifically to put people in the position of those with hearing loss so they can experience firsthand the sensory sort of deprivation and social isolation that comes with hearing disability. James Hullock is another close collaborator of mine, who's also a visiting fellow. And we've been working together on a number of projects, which I'll expand on a bit later. But we are currently working on a project called Disruptive Critters, which is a sort of an AI based audio visual interface that's really exploring sort of performative sound art practices that sort of emerge when you sort of combine autonomous computer generated agents, sound, and interactivity. And we've done a number of live performances. I'm not generally a performer in terms of getting up on stage and performing, but James has encouraged me over the last few years to participate in these types of performances, which has been an interesting experience. And also a recent PhD graduate, Andrea Rassel, who has been working at the Micro Nano Research Facility at RMIT, where she's been developing moving image techniques at the nanoscale. So she's been working with technology in the facility, which is called the atomic force microscope. And what her research has been really interesting in terms of how the scientists who work at that facility have been able to learn new filmmaking techniques using technology that generally has never been used in this particular way to make moving images of phenomena that's happening at the nanoscale. And so this has actually been providing the scientists with new insights about the atomic structures of materials and how they perform over time. And so that's actually led to some quite significant publications for Andrea. So my own where my own sort of practice actually meets science has actually been through projects that have been funded through the Australian Research Council and the Australia Council for the Arts, beginning in 2006. With the first project that we developed, which was called Elements, a virtual reality augmented workspace for movement rehabilitation of traumatic brain injury patients. And that's the project that we're still currently working on and evaluating, and also recently working with Gillian to see how we can advance this in the applied space, where we essentially can commercialize technology like this in the health space. That project led to another Resonance, which is a digital media artwork for cooperative group interaction in the rehabilitation of acquired brain injury. And more recently, Playboards, which is an app understanding this type of technology in for older residents in community care. So we have a number of, so these projects have all sort of formed through sort of multidisciplinary networks of teams over essentially a 12-year period that's sort of bringing together interdisciplinary expertise in digital design, games, computer science at RMIT, developmental psychology and neurorehabilitation, the Australian Catholic University, as well as clinical psychology in understanding the emotional well-being of older adults living in residential care at Swinburne University, and also physiotherapy and occupational therapy at the Epworth Hospital and in Melbourne, and Prince of Wales Hospital in Sydney. And that's spread out into other areas of community arts and disability, which is through James, through his arts organization called Jolt Arts, as well as moving more into the research translation space with business strategies and commercializing sort of these types of technologies in the healthcare sector. So the system we've developed is as part of this research is a set of called EDNA, is a set of interactive game-like applications which are designed for movement rehab for brain injury, such as stroke. And these activities include environments that encourage sort of collaboration, challenge, and creative modes of user interaction, really designed to engage patients in their rehab. So the technology combines, it's a digital tabletop touchscreen monitor and or smaller tablet. We have a range of what we call tangible user interfaces, which the patients interact with, and a suite of sort of interactive game-like applications that really that participants play with, and they can use these environments to do a range of activities. They can, some of them are creative, some of them are competitive. They can use these applications to compose with sound. They can create artworks. And the actions they're really simple in form, but they're sort of playful in their effect. And essentially they're designed to better accommodate the physical and cognitive limitations of many of our participants in our studies. So our team took a sort of research approach that spans a sort of design, arts and science domain to really sort of tackle the complexity of designing for brain injury. And we explored a sort of range of sort of guiding philosophies to help direct the design and the research. And to design the iterations of our system, we sort of utilize concepts from embodied interaction design, which was a theory developed by human-computer interaction designer Paul Durisch. And that embodied interaction provides a sort of a design framework that focuses on a first-person lived body experience and its relationship to the environment. And what's interesting is Durisch's perspective really sort of attempts to sort of unify the physical affordances of the world and the computer world through a design approach that sort of relates to developing user interfaces that closely match our everyday experiences and abilities. And essentially, in short, sort of designing user interfaces and user interaction that is more natural, it's tangible, and it's intuitive to use. So this sort of the relationship sort of between the body and the screen is something that's sort of fascinated me for some time. So way back in 2005, I sort of began investigating that sort of physical properties of digital media and really sort of treating the display as a physical material and creating an artwork, which was shown at Acme called Black on Black, White on White. And this was an international exhibition called White Noise, which was exploring abstraction through the moving image. The installation that you see here is 3 horizontally mounted LCD panels that are actually stripped bare of their enclosure. And there's 3 panels, each one is rendering a black colored animation on a black background, and the opposite is rendering a white animation on a white background. And the only way that you can actually see the work is by changing your viewing angles. So if you might recall sort of earlier sort of LCD screen technologies, that if you weren't looking at the screen dead on, it would start to shift color spectrums. And this was through the polarization of the light that's going through the screen. So that the idea is that viewers, in order to see the work, very much like artists such as Ad Reinhardt, who use similar techniques but with paint, is that you can actually only see the artwork through sort of changing your relationship to the screen. as you might with Ad Reinhardt's painted works, that the way that the light is captured on the paint reveals the artwork and what essentially looks like a blank canvas when you initially approach it. So this was one of the areas that I looked at. Was caused a lot of frustration for gallery visitors who thought, oh, it's broken. It's like, no, it's not. So it was an interesting artwork. It received a lot of comments. And then in 2006, 2007, I really began to explore horizontal computing sort of form factors through commercial development of large format interactive multi-touch displays, both at originally in the Eureka Sky Deck in Melbourne, as well as an installation called Serendipity, which was a 6 meter by 2 meter long interactive touch display. And we worked with a company that developed the PlayStation iToy to develop a multi-camera tracking system that could actually detect where people were touching on the surface. We then expanded that out to create circular multi-touch surfaces in an installation called Drops of Wisdom, which is at Warragamba Dam, which is one of Sydney's main water catchment areas. And they constructed a visitor center to explain all that, a museum that explained what the water catchment actually do there. And so we developed a circular 3 meter diameter multi-touch surface which revealed stories about the water catchment. And we recently refurbished that installation last year. So taking those sort of concepts of sort of horizontal computing further is sort of incorporating more tangible and embedded user interfaces for sort of interacting with digital things via sort of physical artifacts, which we explored to develop EDNA. And really the main objective of rehabilitation and therapeutic exercises is improving the patient's motor functions and maintaining their physical skills. However, as most rehabilitation exercises are repetitive, which is essentially performing the same motion at multiple times, the result is that patients are often not motivated to continue after their initial treatment. And so our strategy was to sort of incorporate creativity and playful activities with these tangible interfaces towards sort of motivating and engaging patients in performing sort of action-centered sort of movement skills. However, designing for individuals with brain injury is incredibly challenging. Essentially, it's staggeringly sort of 1 in 6 people will suffer from disabilities arising from an acquired brain injury in their lifetime. And with stroke, the peak incidence, for example, is over the age of 45. And with traumatic brain injury, it tends to be younger males between 15 and 24. It tends to be more sort of falling off workplace, ladders and motorcycle accidents and the like. And so the effects of the brain injury it often has sort of broad impacts on both sort of motor and cognitive systems. The optimal sort of treatment window is usually in the first sort of 6 months of their sort of post-injury. And as I mentioned, the physical therapy works, but it's repetitive and it's very labor intensive. It also affects about 500,000 Australians, or there's approximately 500,000 Australians living with disability as a result of ABI. And one of the things that often results in is impaired hand and reach function. And recent sort of surveys with patients, they actually rate the recovery of their upper limb function. About 80% rate upper limb recovery function as the priority for many patients. This diagram here essentially shows the sort of repercussion cycle of what typically happens to a person after a brain injury. So the cycle starts with the initial brain injury, and this leads to sort of a variety of sort of physical, cognitive, emotional, and sort of behavioral deficits. And then these problems can interact and combine to create sort of psychosocial problems, which can create new problems. And so effectively, brain injured patients can experience difficulty in performing many sort of daily living activities and self-care. So taking on board some of those concepts of embodied interaction and embodied cognition, our design process sort of led to what we call six goals that we envisaged. The design of what we call a preferred state of an upper limb rehabilitation system that sort of guided our initial design prototypes, and that was accompanied by sort of user testing and reflection. And just working through those, we wanted to create an interactive artwork for movement rehab that sort of provides opportunity for creativity and play. We wanted to engage and motivate patients in therapy. We wanted to create a physical user workspace that enables a sort of a more direct, non-invasive form of interactions. We didn't want to tether the patients to any form of sort of wearable sensors, as we saw this as sort of potentially sort of distracting and unwelcome. We also wanted to develop those user interfaces that sort of capitalize on our sort of natural physical abilities and how we manipulate objects in the real world. We wanted to have real-time interaction, tracking, and recording. And importantly, we wanted a sort of ease of operational use for the therapist as well as the patient. So what we've developed the system into now over many years of research is called EDNA, which we've called the world's first brain injury rehabilitation system to integrate clinic and home-based therapy. And that consists of what we call EDNA 55, which is a large tabletop interface which is used by therapists in the hospital. And then EDNA 22, which is a device that patients can then use in the home. And so the performance data from both of these devices is captured in the cloud, and the therapist can actually customize the prescriptions, which are then pushed to the patient for remote and intensive therapy. So how does that work? It's sort of, so with the therapist will access essentially a web portal where they can access a set of recommendations based on the patient's age, their health condition, duration of, and also they can set the duration of therapy, and these can all be considered in the interface. So then the therapist will, through the website, can tailor a sort of specific treatment plan. That prescription is then pushed to either the tabletop device or the tablet-based device. The patients then perform those tasks either in the hospital or in the home. Those measurements of their performance, such as their accuracy, their efficiency, their reaction times, speed, time on task, and their compliance and adherence can all be recorded and stored for the therapist to review and then present back to the patients as they progress through. So in the base system that we have at the moment, there are others, but we've started off with a set of 7 sort of interactive environments for our goal-directed tasks, and then 8, and then we have a number of exploratory environments as well. On the tabletop surface, we can facilitate group modes of interaction between 2 to 4 patients, which are sort of designed to really enhance that sort of social engagement and inclusion for the patients, but also to be able to sort of learn vicariously through the sort of shared learning and communication between patients. So this happens on the sort of larger surface, and the smaller one that the patients can either practice in the hospital at their bedside, or in the event that they're an outpatient, they can take the device home and continue with their therapy. So there's a number of features that we have implemented. So again, we have these natural user interfaces. There are a sort of variety of shapes that sort of challenge the patient in terms of how they hold and grasp the objects. And that correlates to some of the tasks where some of the patients, for example, have to rotate the rectangular block accurately onto a target. So these are some of the sort of range of, so the range of motion is more challenging depending on which object is selected. The cylindrical object is the easier object to use for the patients to start with. We also, as I mentioned, we are recording data that is then presented both to the therapist and can be presented as a report back to the patient, but also in-game or in-application feedback as well. So there's a set of, the patients are rewarded with sort of personal best, depending on how they perform, as well as their achievements in terms of, you know, how quickly they've been able to move, and so on. So they're presented both in-game, but also at the end of the session, where they can actually review how their sort of tally's going in certain areas. So this is one of the exploratory tasks that I'm going to show, which is it's a musical instrument where, and if I just play this, when you place an object on the screen, subdivides the screen into these sort of petals, and each one is like a keystroke, or if you think of it as a keyboard. And each object has a different set of instruments, and you can combine those instruments and you can mix different colors, almost indicate. You can also use where you can spin down. The sound is spatial. Slow down the sound, you can reverse. And then the last, so what we found with this is that even with the slightest movement of these interfaces, you can actually create some fairly complex compositions with minimal of effort, which is what we're, you know, in many cases, our participants will struggle to move these objects. So we're really wanting to encourage and engage them with this. And again, in a group activity, they can see others interacting with it, and they might want to try something out for themselves, and we want to see how they play with it. So this has led to, so this particular environment led to a sort of quite an unexpected turn for us, actually, when we took essentially took the system out of this sort of clinical environment and presented, you know, the work in the public domain. And I formed a partnership with Jolt Sonic Arts, who was working through James, who was working at the Footscray Community Arts Centre at the time, and he was working with an ensemble of musicians called the Amplified Elephants, who are an ensemble of musicians with intellectual disability. And so that collaboration with the Amplified Elephants and James as their mentor resulted in sort of several public performances where we were using the interface in the Melbourne Festival, and Bendigo Festival for Exploratory Music, and Melbourne Music Week. So we developed in developing these performances, we could see how it was used by a different population, and how intuitive the interface was to someone, to a completely different group. And sort of based on the positive feedback that we were getting from the festival performances, we wanted to expose the system to a wider audience. So we developed a performance in concert with 4 percussionists of a group called the Bolt Ensemble for a work that was called Resonance in the Dome, which was shown at the Design Hub Gallery at RMIT. And they'd set up an installation which was I think it was a 6 meter wide or something like that, dome projection system, which is essentially a hemispherical display, which is suspended over the audience. So the audience are sort of lying back on bean bags, and they're sort of watching the performance take place. And I think this might be. So what we found is that through this sort of process of engagement across sort of many different communities, when we took this out to Sonar Festival, which is a sort of large electronic music festival in Barcelona, and that was where we really got to test the system out with DJs and all sorts of electronic artists, and that was an incredible experience, where we would have had about, I don't know, maybe about 5,000 visitors who came through, tried it out. We had some luminaries come through as well, such as Brian Eno and others having a play. So it was an extraordinary experience to actually see how the public engaged with it more broadly. And so what we found is that through that sort of process of engagement across many different communities and research domains, we've been able to sort of refine and adapt the system into different contexts. And the system is extended sort of well beyond its original design, from sort of clinical rehabilitation use towards an instrument for musicians with disability and professional performers. It can be networked as a controller to manipulate large multi-projector displays of the Dome Lab. And so what we found is that this original design has really become sort of entangled across sort of multiple domains and disciplines. So really some sort of concluding thoughts here is that, we found that, sort of multidisciplinary collaborative approach to this multifaceted problem like rehabilitation is essential. And specific to sort of design, people need their interactions with technology to be simple, intuitive, pleasurable. And research collaborations, in my view, and this is something that, that they should be open to different approaches. They should tolerate failure, they should embrace risk. And we found that sort of design and science and humanities, and together they can really sort of contribute sort of new research insights that, neither one could do alone. And so in our research, there was a sort of a complex arrangement of stakeholders, and it continues to grow as a complex arrangement of stakeholders. And we found that really, that the project sort of gains that sort of acceptance through these sort of multiple avenues of user engagement. And in our case, it's from the clinic to the community, it's exhibited and it's performed. And with each outcome, the system is iteratively improved. And really sort of finally, that sort of design, that creativity, it offers opportunities to simplify and humanize technology and develop sort of emotionally sort of resonant products, particularly in the rehabilitation field. And of course, the importance of working in the sort of health space is the importance of it being evidence-based. And of course, this takes a considerable amount of time. Anyway, I might stop there and thank you for listening to me. I'll stop sharing.
All I can say, wow. And I'm going to ask the first question this afternoon. I would love to have you on again next year, talking more specifically about all that very last point you made, the complexity of the scale of the project, how you pull people together. Because I think in some of the simulation work that we're seeing, it's got to be multidisciplinary, it's got to be interdisciplinary, but what are the traps and pitfalls and how do you come over that? So I'm sure I'll be back in touch. But for today, how do the people with brain disabilities, what's their reaction the very first time you sort of present them with something like this?
Well, that's a really good question. So the first trial we did at Epworth Hospital in Richmond, the patients actually reported back that it was the highlight of their week. We thought, wow. How's that? What do you mean by that? And they said, well, they actually looked forward to the opportunities that they had to use the system because they felt sort of that, the other rehab activities that they were doing, they just found them tedious and just lost interest in them. But for some reason they would remember to come to their session with us when we were trialing the system initially. Which they have their own sort of diaries on their phones to sort of prompt them to remember where they have to be at certain times and so on. But we had a really high success rate with, we didn't have any patients drop off out of the studies that we've done. And yeah, that was their reactions were varied depending on their age group. So the younger participants, so the participants who had traumatic brain injury, who tended to be sort of, as I mentioned, male, they could relate to it based on the technology that they were accustomed to before their accident. So PlayStation, game technology. So they could, for them, this was a sort of novelty factor for them. Like they hadn't seen anything quite like this before. And so they were very willing to engage. With older participants, it does vary. Again, there's a sort of a novelty of the technology, but one of the things that that the occupational therapists have mentioned to us, and it doesn't matter what you present in front of the patients, they have to be motivated to get better. And it's surprisingly a number of patients are not motivated in their own therapy. So you present something like EDNA to them, it might change for them. They might get more interested in the activity in terms of what they're doing and participating in their own treatment. But many drop out. They just have, they suffer from so many complications and mental health issues as well as a result of their, stroke, or, many will suffer from depression. They don't really engage. They can be quite aggressive. So we find that using technology like this can sometimes change that dynamic between the therapist and the patient the patient can be more curious about what it is they're actually doing. Because essentially it's replacing therapy, which is like, this is how you hold a cup, and this is how you lift the cup onto a shelf. Now do 100 times, and then we'll see you tomorrow, and we're going to do the same again, and we're going to do the same again. So, I mean, you can see why patients tend to get disheartened with it after a few weeks. Yeah.
So, Jonathan, can I just ask a question? Derwin Shepherd from Monash. I think it's an engagement process that you've got going in the first instance, and that's good. I'm just wondering when you just mentioned about the cups, I thought, yeah, the visual and auditory cues are laying down new memory and different memory to what they're normally doing it with replication of cup movement as opposed to the interaction like in a movie. And it's more immersive for them. So I'm just wondering, and I'm not a neurophysiologist, so I'm just wondering whether that actually lays down new memory, even if they've got a stroke. I'm sure you've got some colleagues that can explain that more effectively.
Yeah, so one of the things that's important for our research team is that the tasks that they are doing on EDNA are ecologically valid, so that they do actually translate into an outcome that's relevant in the real world. So that's very important. We don't want them to just get good at playing the games and doing the activities if it doesn't actually have an impact in the day-to-day functions. So the way that a number of our trials have been set up is to actually look at how, based on the training that they're getting on EDNA, whether that actually transfers to real-world skills and not just, scoring well on EDNA tasks. And so that's one of the key insights that we found through some of our published research that is actually occurring, which is, it's very, very positive.
So are you demonstrating they're developing new neurological pathways?
Yes, well, that's possible. We haven't got to the point where we're sort of measuring that. But we are seeing that there's performance increases in our randomized control trial that we did last year, that we were finding 2 to 3 times greater improvement than treatment as usual, so which is quite significant. So what's happening to the sort of gray matter and the white matter, and whether new pathways are being, we don't know. We'd assume that may be occurring, but that's not something that
I'd be interested to know how quickly you could bring it into the acute phase. My background's intensive care, so you've got someone who's awake and ready to go into rehab, but how soon do you initiate this stuff to help that rehabilitation phase? How far do you push it back?
Yeah, there'll probably be usually in the first 6 months after the injury is the sort of optimal period of time, because the brain is still healing at that point, after which, if 2 to 3 years after stroke, you
Yeah.
may see any improvement over time. So it's better for sort of early intervention rather than after. But it's a good point. I'd have to speak to one of my colleague about that, because there is some evidence that they're seeing improvement on participants who are post-stroke by about 2 to 3 years, but it's a different study.
Yeah.
It's using a different set of tasks that we've also designed, but I've not talked about today. So yeah, it may be possible, but we haven't tested in that population.
So I come from a pedagogical driver, so I could see that the whole experiential exercise is fairly deep, and there's a few other education theories involved in what you're doing. So have you actually thought about how that's underpinning what you're doing rather than just the lights and sirens?
Oh yes, so no, definitely. It's I mean, we're looking really through that sort of lens of well, my lens is through that sort of HCI area of tabletop interaction, which is really around that sort of levels of collaboration, cooperation, and competition. Using interfaces like this in a sort of learning context. So that's some of those sort of theories sort of underpin our approaches to it. And interestingly, those sort of collaboration, cooperation, competition, there's not really any clear preference from patients. Our occupational therapists would say, oh, we think competition, you know, making the game environment would be really compelling for patients. Not always the case. And then when you sort of dig in a little bit deeper, the occupational therapist is a big sports fan, you know, so he likes it. So it comes down to a range of personal preferences in terms of those sorts of modes of learning for individuals and the groups as well, because they do conduct group therapy as well, whether it's circuit training or, you know, the likes.
I'm wondering whether you could measure how much social and cognitive constructivism takes place with that intervention.
Yes. We haven't measured that specifically, but yes, it's certainly there's definitely a sort of sort of vicarious learning that's happening when they see someone perform a certain task in a particular way, and that person's then thinking, "Ooh, I might try that."
Ooh,
or
that's different. Yep.
Well, that's different. I'm going to try something similar or something different.
So you are rearranging the way they think, see the world.
Yeah. There was one example that we had was a patient, diverse age groups. One was a traumatic brain injury patient who his injury was through drug abuse. And then we had an elder participant who had stroke. So I think the ages were 20 and 79, I think. And so we got the two of them together, and it was amazing to see how they collaborated together, particularly on that musical one that I was showing, where they sort of worked out strategies to sort of play and perform together without ever having seen the interface before. They didn't know what to expect. So they, you know, over a 10-minute session, they sort of strategies to work together.
Well, music is genetically embedded in us, you know that.
Yeah.
It's Marcus Watson here. How well do this, it's a two-dimensional screen, and there's sliding motion, so they're getting two-dimensional motions. How well is that transferring to the full 3 dimensions that they have to operate in?
So there are tasks as well where we require the participants to lift the object based on sort of stimulus that's prompting that. So it's sort of gross motor skills. It's not fine that we're measuring, but it's on we're not tracking the sort of kinematics, if you like. So we're not necessarily tracking the sort of limb position and movement per se, but it's more to do with how they're responding to the stimulus on the screen. So what we are seeing is that even with those tasks where they're lifting, placing, because a lot of these patients have fatigue as well. So some patients cannot actually lift the object, which is why we sort of have this slide, predominantly slide function that you saw. Because they have, I can't recall the condition, but essentially they're, it's almost like a dislocated shoulder, and that's essentially what it feels like for them. And I think they get sort of muscles that relax and the whole shoulder collapses, and it's extraordinarily painful. So those objects that you see there are sort of light plastic, conductive plastic objects that, you know, they're very, very light, like a small plastic tumbler or something. But even then, patients will struggle to lift. But we can vary the weight of those objects as well by giving them different objects to use, and encourage them to lift where the tasks actually provide that opportunity. So we're what we're measuring are things like placement accuracy, so endpoint data rather than sort of kinematic sort of limb position. But it seems to be translating in terms of how their everyday functioning is being measured.
So you could use a HoloLens too, and mixed reality approach.
Interesting you should mention that. We've just got funding to do a project around that in that space. We found out today, actually,
Okay.
which is using the HoloLens for exactly that.
We're just done a proof of concept for training surgeons in that space using HoloLens too.
Oh, right, terrific.
So interested to talk to you about that.
Yeah, absolutely. Yes, I sort of dabbled with the first HoloLens, but
not good enough.
It wasn't good enough.
There's a couple of other headsets available. I mean, but if you can do visual tracking and hand tracking, that would be good data to collect.
And I've noticed as well with you know, technology like the Oculus, like the tracking on that is actually, that's really quite robust, surprisingly.
Yeah, we use them too, but
but I find that in rehab space, virtual reality is problematic for a number of reasons. Again, a lot of stroke patients have things like diplopia and so on, which is sort of weakness of eye muscles. And so stereo headsets are really problematic in that context. It's also very disembodying as well. We want the patients to be interacting in the real world with real objects. So I think that's where AR really offers some interesting opportunities there.
Yeah, I think the HoloLens 2 and whatever comes after is actually, it's number 20. They call it the HoloLens 2, but it's about the 20th version of the HoloLens.
Right.
I just don't tell you how many times they've failed developing it. Yeah, that would be an interesting bit of work to talk about.
Yeah.
Sorry?
Did you say you were at Monash or Melbourne?
Yeah, Monash. We have a virtual and augmented reality service.
Right.
Serving universities. So.
Sounds like you two need to get in touch.
I think so.
Yeah.
Absolutely. Sounds good.
Okay.
And bringing in FIT and engineering people like that, they're really helpful to make it work.
Right. Oh, well, maybe.
I'll connect your emails.
Yeah, good.
Yeah. Are there any other questions? We're pretty close to finishing. I think Jonathan could talk all afternoon, and I'm really looking forward to a session next year on that complexity of team stuff. But for this afternoon, it's been amazing just to sort of see what's being done now. The reason I asked about patient responses is my mum had a stroke after she was 60. And watching her go through rehab was a very painful process. Not a lot of joy at all. Enormous commitment, but yeah. And this looks like it adds some joy and some sense of fun and play to what is essentially a pretty painful and difficult period in someone's life.
I was going to add, Jonathan, so sorry, Elizabeth, I was absolutely thrilled to see the coming together, you know, modeling, simulation, systems, concepts, really that holistic, bringing together multiple competencies, disciplines, technology, to really, you know, for a better, safer world. I think some of these concepts really apply. You're applying it in a particular context of health and well-being, but they really go across the board. There's so many opportunities for this and for cross-pollination. I had a very quick question, really, if you can. What are some of the challenges you're seeing in some of the potential risk or negative consequences that might evolve or that might inadvertently happen if we're not too careful with this stuff? If there are any that you can sort of think of.
In general or in rehab space?
I'm thinking, actually I was thinking of the rehab space to start with, but in general, but just stick with the rehab space itself.
Look, there's not, I mean, with the technology itself, I don't think it's, I don't think there's, I mean, which is why we've gone with the approach that we have, is that is actually minimum sort of risk in some ways. There's other types of risks, such as privacy, particularly in digital health, that maybe it could be an issue. Injury.
Could there, for example, could there be, as a result of inadvertent application or use of these technologies, behaviors that could be learned or created that might have negative consequences, in a sense that we've got to be careful of? I'm just thinking, if you think about gaming, for example, and how people get really immersed in a game, and you can go into a game and kill people and come back and start again, right? I mean, that's probably pushing it to the limit. But that type of thing, where you can get away with some stuff in this context that really we have to be careful of, and when you put it into the real physical manifested reality, it's probably not quite the same.
Yeah, look, I get your point. I mean, I think, I mean, the way that our approach has been is creativity in the sort of content and the application in terms of how we've approached this, and rather than content that's perhaps risky or.
Right. So you're implicitly doing that yourselves, and
yes,
and how it's, yeah.
I mean, where the risk might come in is that and we have found this with one with one participant. Again, it was in a different study using a different application where the participant used it solidly for 2.5 hours, to the point where that's not safe, because then you're introducing things like repetitive strain injuries and so on. But one of the things that we have done is in the EDNA system is it's prescribed. So when you finished your prescription for the day that's finished, you can't actually relaunch it again until the next day.
Right. So you put a safety envelope around it, in a sense that tries to minimize those things, and you continue to evolve that as you learn more, really.
So it's like, okay, the system is set up that you can do, the prescription is set up that you can do 30 minutes per day. There are some tasks that you can free play in. So if you think, well, I've done my 30 minutes, but I want to keep playing, you can do that, but the data is not being recorded. Right. And also you will receive prompts that remind you, it's like, you are finished for today. Would you like to get
we actually have a health and safety policy now, just launched, for the use of all immersive technologies as a standard precaution thing, and even COVID related things, and it links into our risk management process, so that everyone who's developing anything has to go through the risk assessment process before they do anything else. And I think we have to build, from a quality perspective, we have to build that sort of thinking into program development. Exactly
right. Exactly. It's those architectures and templates that we use have to be extended now for this stuff, because it's actually pushing the boundaries. You're going to pioneering, into new territory here. And so,
is that public?
Our stuff?
Yeah.
Good question. Let me just suss that out.
It's just that if you've got any university with a site that feels they've got enough evidence behind it, I think that's fabulous. I continually get asked, what's the limit that people can do? And I keep on telling people, well, there isn't limits, there's considerations you need to think about that will be different for each individual. But it would be great if someone has a guide for that I can point people to.
Okay. Yeah, I have to go to another Zoom. I'm being Zoomified all day today on my day off. Great to hear what you had to do, what you're doing, Jonathan.
Yeah.
And we might pick you up on that safety document. That sounds fabulous.
Yeah.
And Jonathan, that was, well, clearly we've gone over time. So that was really good. Thank you.
Yep.